Hello everyone, welcome to Organic Chemistry Lecture 7, Alkyl Halides. This lecture is dedicated and present to the University of Comar for Science and Technology, College of Medicine, and Department of Pharmacy, second year Organic Chemistry. Alkyl halides are one of the important molecules that we have it in our daily life in the drug structure, usually represented as an R and X. The rest of the structure called R, and that bit is Cl. These are two drugs currently in use very widely. Let's talk about alkyl halide and the chemistry of alkyl halides. According to the classification, we can have primary alkyl halide adjacent linked to the primary carbon, secondary alkyl halide linked to secondary carbon, tertiary alkyl halide linked to the tertiary one. The nomenclature of alkyl halide is exactly similar to the nomenclature of the other classes of the organic chemistry, like alkene, alkyne, and the others. The longest chain, parent chain, and the branched, the more heavier side, alphabetically we order it. It is D, this is B. Why 2-bromo, not 5-bromo? Because the naming, if the two halides or alkyl are equal distance at the end of the chain, begin at the end near to the substituent whose name comes first. I have methyl and I have bromine, B, M. We start with 2-bromine, not 5-bromine. Which one is heavier? The bromine is heavier. We start 1, 2. And why we are saying 2-bromine, not 5-bromine? Because of the alphabetic order. Something about alkyl halides. The alkyl halide, the carbon halide bond is longer, is weaker, is polarized, is good living group. Longer, weaker, polarized, and good living group. It's good living group. That is why in any chemical reaction the halogen usually expel easily. We studied that in the chemistry of alkane. I'm not gonna repeat it again. Just know that with the presence of heat or light, substitution of hydrogen to halogen can take place. Preparation of alkyl halide. I have this double bond and with HCl. According to Markovnikov, H will come to here, a cation will be created here. If the cation created here, this bond will form, but this is not formed. According to Markovnikov, H goes to the richest carbon in hydrogen. The richest one is 2 hydrogen, the poor one is no hydrogen. That is why the H come here and the positive here. Why this rule of Markovnikov works in that way? Because the cation will be at more substituted carbon. In that case, when we are saying the more hydrogen, the hydrogen will go to the more hydrogen substituted. It means the positive charge will created in the carbon next to it. When a carbon has less hydrogen, means has more substitution. When it has more substitution, the cation will be more stable. So we can say the Markovnikov as like that. The hydrogen will go to the carbon with enriched in hydrogen, or the halogen will go to the cation which is more substituted. the OH changed to X. Conversion of alkyl to alkyl halide with the presence of HX can be done that easily here at low temperature. Remember, tertiary, secondary, primary methyl. Tertiary is more stable. What is more stable means? It means it is intermediate, is more stable. When the intermediate is stable, the molecule itself is more reactive. The less stable intermediate, the molecule itself is less reactive. So as long as the stability of intermediate increase, the reactivity of the molecule itself increase. As long as the reactivity of the intermediate decrease, means stability increase, the reactivity of the molecule increase. If the stability of intermediate decrease, the stability decrease, the reactivity of the molecule decrease. So more stable intermediate, more stable molecule, more reactive molecule. Less stable intermediate, less reactive molecule. That's how usually with cyanide chloride with the presence of pyridine or NH2R, amine, primary or secondary or tertiary, we can have DEA, diethylamine, or TEA, triethylamine, or we can have pyridine. As long as we have an organic base, we can convert the OH from bad leaving group to chloride, good leaving group. Basic representation, ROH plus HX becomes RX with H2O. Tertiary, secondary, primary methyl. This is more reactive. Why? Because the intermediate of this tertiary carbocation is more stable. This is less stable, that's why less reactive. This is much less stable intermediate, much less reactive. This is the least stable ever, that is why very, very less reactive. The physical property, we have dipole-dipole interaction, we have kind of solubility in water because it has polar structure, their boiling point, and this is something just to know that. We have two things here to understand about the RH, RX and ROH. Alkyl and alkyl halides are similar to each other in their chemical reaction and properties, apart from their uniqueness as a different organic compound, but they are both following elimination and substitution reaction. We can have substitution reaction by substituting X to Nu. We substitute, we exchange their places. And we can have elimination to form a double bond. Always and always, elimination causes formation of double bond. Substitution causes formation of another saturated product. These are general features of nucleophilic substitution. Is sp3 hybridized with a nucleophile, we have a leaving group. Leaving group leaves the structure and the nucleophile will come to the structure like that. These are nucleophile. Nucleophile are negative charge, anion, or lone pair of electron, or enrich in electron. To draw any kind of reactions like that, we need a substitution mechanism. In substitution mechanism, we usually have a back attack. I'm not gonna go to the detail of E1 and E2, SN1 and SN2, because it is difficult for everyone, and you are pharmacists, you don't need it. We should have an sp3 hybridized carbon with a leaving group. Identify the nucleophile, the species with the lone pair of pi bond. Substitute the nucleophile for the leaving group and assign the charge if necessary. Any atom that is involved in the bond breaking and bond formation. This is the overall reaction. Nucleophiles and bases are structurally similar, because nucleophile is base by definition. Both have lone pair of electron or a pi bond or a negative charge. They are different in their attack. Base will attack the hydrogen, nucleophile will attack the carbocation. If we have these starting materials and we have these leaving group, these leaving groups belongs to that. We can have these conjugated acid in the product. They are good leaving group, and the poor leaving groups are these in the nucleophilic substitution reaction. The mechanism of nucleophilic substitution reaction is back attack. The leave is from that side and the attack is from the back side, and we have inversion. We have inversion in the structure. If we have S product, we will have R product. Okay guys, if we have the X on one side, the NU will be on the other side, because when this X leaves the structure, something remains like that. 3 bond, 1, 2, 3. A positive charge will be here, can attack from the front side and can attack from the back side. That is why we have inversion. Cis isomer becomes R isomer. The SN1 and SN2 is substitution nucleophilic second order. Second order means two species have an influence on the rate of chemical reaction. You studied second order and first order reaction in your 12th grade. As you can see here, this is SN2, substitution nucleophilic second order. This cannot leave without the aid and the push of that. And it happened at once. SN2 at once, in one step. And that's the energy diagram of the reactant, product, intermediate. It is one step. And we have said it is inversion. This red will go and this blue will come in. If it is R, this will be S. Remember, do not forget, inversion in the stereogenic center. And there is nothing explained to give details, but remember this rule. Methyl and primary alkyl halides undergo SN2 in one step. Why methyl and primary undergo SN2? Because they have small structure and they have enough room to be attacked at the same time when they leave their leaving group, because they are small and they have enough room space to be attacked at the same time when the leaving group leaves the structure. Secondary reacts very slowly. Tertiary undergo SN1. will not undergo SN2. Why? Because tertiary has 3 big group and a living group, and there is no space between these 4 groups to be attacked before leaving the good living group. Firstly, in SN1 substitution nucleophilic first order, firstly 1 molecule will participate. Then we should allow the good living group to leave the structure and form a cation. Then after that, allow their base or the nucleophile to attack. How? This is the explanation. For the primary, there is enough room. For secondary, kinda yes and no, possible. For the tertiary, it is impossible. If you can see here, there is space. There is space. Oh, no space. For the tertiary, no space for SN2. So SN2 not happening. Happening very fast. This is slow. Methyl as well. Fast. This is the rate of reaction. You study that in 12th grade. You don't have to worry about, because it's second order. Both have an influence on the rate of chemical reaction, and this is a rate constant. You study in your 12th grade first order, second order reaction. First order, one species have an influence in rate determining step. Second order, 2 species have an influence on the rate determining step. Usually second order take place in 1 step. First order take place in 2 steps, opposite to their numbers. This is another example talking about the same thing. This is tertiary. 2-step mechanism. Step 1, formation of the cation. Step 2, attacking by the acetate. This should leave form that then allows to be attacked. Step 1, step 2. This is SN1. Rate determining step, 1 species will participate. In SN2, both of the species have an influence on the determination of the rate of the reaction. Their energy profile. We said the stereochemistry, the attack could be on the top or on the bottom side, because we have a positive charge, and the sp3 cation, the sp2 cation have 2 flat face. However, there is possible to attack. When you study the mechanism, you should understand the idea which one is favorable, from the left or from the right. And that is all examples to tell you that structure and that structure. We have same configuration, inverted configuration. Which one possibly attack? Repeating that. Then we are talking about the SN1. Methyl is SN2, primary is SN2, very slow SN2, very fast SN1, very fast SN1. Opposite to SN1. If you have understood the SN2, SN1 is opposite. When we have methyl converted to that, when we have primary to that, secondary to that, tertiary to that, let me tell you something here. This tertiary cation is much stable than all the others. More stable, less stable. Okay? In that structure, there is possible to nucleophile to attack on both sides, but here there is no room to attack. Here there is room, space to attack. However, the nucleophile has a favorable collision, will form a product. That is why this is SN2. SN2. Very slow SN2 or SN1. SN1. You should recognize the weak and strong nucleophile. Strong nucleophile you studied in the first semester have a negative charge. Weak nucleophile usually have a lone pair of electron. Favors SN2, favors SN2, decreasing the rate. More example to explain the idea of SN1 and SN2 and the solvent effect of good and bad leaving group. If the leaving group is good, the rate is faster. If the leaving group is bad, the rate is slower. Solvent effect not included for you guys to study. Not included. Elimination reaction. So E1 and E2 reaction. How elimination reactions work? Elimination reactions work for alkyl halide, RX, and alcohol, ROH, with the presence of, for alcohol, acid, for RX, base or alcoholic base. Why alcoholic base? Because alcohol increases the basicity of the base itself. The base in alcohol are more basic than the basis itself. So when you dissolve a base in alcohol, the basicity of this base will increase. The BR's good leaving group goes away and the base will obstruct a hydrogen and create a double bond here, as you can see. This is for E1. Elimination first order. Elimination first order. Elimination second order. This is one step. This is two step. Okay guys, step 1 cation formation, step 2 obstruction. But one step, this go away, this comes here, this hydrogen will go. When the E1 will take place, when the E2 will take place. Elimination form a double bond, also always minus HX for RX and HOH minus HOH for ROH. If you are doing elimination for alcohol, you have to minus HOH. If you are doing it for RX, you should minus HX. So between substitution and elimination, I'll send you a single page that tells you everything about it. The strength of the nucleophile, determines the order. The nucleophile or base promote bimolecular reaction. So the nucleophile will increase the rate of bimolecular, means SN2. Primary halide usually SN2, methyl halides usually SN2, secondary halide sometimes prefer SN2 but very slow reaction, mostly SN1 or E1 and E2. So tertiary definitely is SN1 or E1 or E2. High temperature favors elimination. So when the temperature is too high, it helps elimination reaction. When we have a bulky base, favors elimination. Let's talk about the E1 mechanism. E1, we said it is two-step mechanism. Step 1, creation of the cation. Step 2, removal of the hydrogen, creation of the double bond. That's the explanation. Closer look. We have that condition. The base will attack the hydrogen and the bond here, which has an electron from the carbon and an electron from the hydrogen. The base will just need the proton itself positively, H+. The two electrons of the bond will remain for the carbon sp3 here, and the two electrons with an empty orbital make an overlap and create a pi bond, like the green 2 black dot representation explain it. That's the E1 diagram. This is just a pattern of double bond, mono substitution, di, tri, tetra. We have Zeit-Sief rule. Zeit-Sief rule. Zeit-Sief says what? If more than one elimination product is possible, the most substituted alkene is the major product. The most substituted alkene is the major product if more than one elimination product is possible. The most substituted alkene is the major product. How? He says the most substituted intermediate will be created or rearranged to the most substituted. If you have more than one intermediate, which one is most substituted, that one is the product majorly. If you have positive charge here, or if you have a positive charge here, which one is more substituted, the one will be the higher yield product. E2 mechanism. Elimination second order. If you look at the yellow box, SN2 is too hindered. That means too crowdedness. The base will take the hydrogen away. The bromide is a good leaving group, goes away, create a positive charge, and the base will attack the hydrogen. A negative charge will come to form a pi bond. With the positive charge, like the overlap that we have explained before. We have a positive charge and we have two electrons from the bond of hydrogen and carbon. So the hydrogen here goes as a proton, H+. The electron of hydrogen and the electron of carbon, this lone pair of electron, will create a bond with the carbocation. The question is it possible for the base directly attack to the carbocation? The answer is no, because it is too sterically hindered. The order of reactivity, we explain it: tertiary, then secondary, then primary, because of the stability of their intermediate. We may have a mixture, but surely we have one major product and the other one is minor. Which is the major product? The more substituted product, alkene. Alkyl halide and protons to be abstracted must be anticoplanar, means have 180 degree for the elimination to occur. The orbitals of hydrogen atom and the halide must be aligned so they can begin to form pi bond in their transition state. The anticoplanar rearrangement minimizes the steric hinders between the base and the leaving group. This is hard, but let's explain it here. Firstly, it is anticoplanar, means on opposite side. The halogen will go away from one side and the base will attack on the adjacent carbon on opposite side. This is not gonna happen because of the repulsion, the down one. The up one may happen. Anticoplanar may happen. Syncoplanar will not happen. Tertiary is more reactive than secondary. The strength of the base is not important. Ionizing of the solvent, we are not talking anything about ionizing product. The ZC product, the more substituted alkene. You can eliminate that slide before and consider that, because everything here is explained very well. What we have, what types of halide? Primary, secondary and tertiary. And what type of elimination and substitution we have? We have substitution nucleophilic first order and second order, elimination first order and second order. For the primary, SN1 does not happen because we have nothing to stabilize a primary cation. But SN2 is favored because in SN2 everything happened in one step. Imagine if for the primary SN1 happen. SN1 is two-step. A cation will be created, and you know that the methyl and primary cations are very less stable, intermediate. If the intermediate will be very unstable, how we can have a product? That's why we are saying it does not occur, but for the second order is occur. For E1, for the same reason, yes. For secondary, for the secondary, SN1 and SN2 are possibly to happen, depends on the solvent, competition of the base and the structure of the substrate. If we have benzylic and allylic halides, SN1 may happen. SN2 is in competition with E2, and heat plus the solvent is an important factor to decide which one to happen, SN2 or E2. Tertiary always favor the SN1 and favor SN2 because tertiary is crowded, very complex, doesn't allow to everything take place in one step like in happening in SN2. But the tertiary allows to the leaving group leave the structure after creation of a cation, then the base will attack in the opposite side or same side. So let's talk about the elimination for the tertiary and secondary. The elimination first order for the secondary and tertiary could happen independently based on the substrate and the base on also the solvent. With the presence of strong base, E2 is favored for secondary and tertiary. And that slide is the slide that I promised you, and I will send it to you separately, that each of the case of E1 SN1, E2 SN2 for primary, secondary, tertiary, for strong and weak, to understand better. This slide is not included for memorization, but to understand better